go over the content of chapter 10 that talks about inheritance. Again, this is to support our discussion in class. Most of that stuff is straightforward reading, and as I mentioned earlier, whenever you go through code, I do advise that you spend time trying the code out to see by yourself how things work. If you have any questions, you can email me or come to the office. So I'm just going to go over this content and highlight few things and then move on to chapter 18, graphical user interface, and spend more time there. I don't want to bore you with things that that you can figure out on your own. So inheritance. So since we finished in chapters 1 through 7 the basic elements of programming, when we covered data and variables and covered the control structure, loops and selections, and covered the methods and modularization, and covered the arrays and collections, we've been spending some time to talk about classes and relationships between classes. So we mentioned that a class is a unit of code that represents a concept or enable us to represent a concept in real life or an imaginary concept into our software. So a class, so when you have many classes in your program, the question comes, what is the relationship between them? And we discussed one type of relationship, which is interface, and we said that a class implements an interface, and when a class implements an interface, they are required to provide a definition or implementation of all the methods that are contained in the interface. In other words, the interface is a mechanism for somebody who's developing a class or a framework to set some contract with anybody who wants to use their framework. For instance, the event handling mechanism in Java, the way it was designed is to support multiple events and to connect the Java runtime environment with the operating system and enable the user to take advantage of the sophistication of the operating system and the runtime environment. In order to do this, they developed interfaces which contains the contracts that you need to follow if you want to implement or use that framework. So that's interface. Inheritance is another mechanism that provides relationship between two classes. In inheritance, you say one class extends the other class. We have used inheritance before without really knowing whenever we wanted to create a component. When we create a rectangle component or a cloud component or an Olympic ring component, we say for it to be a component, it extends J component. We had this keyword extends, and we follow by the class that we want to extend. We used to extend J component, which should provide us access to the method paint component that is automatically called when the application you're drawing is painting itself. So inheritance, when one class inherits the other class or one class extends the power of the first class. So the class that you create is called the subclass or the child class, and the class that it extends is called the parent class or the superclass. So the child class extends the superclass, or the subclass inherits the parent class. When you inherit or extend a class, all the members of that class becomes your members as well. So if you have a class that has methods and has variables and you extend that class, all the methods and variables become yours as well. And that's how our classes had access to paint component, and that's why if you miswrite public void paint component graphics G, it will not work. And some of you went through this. So in inheritance, It allows us to provide a hierarchy of concepts that relate to one another in an extension relationship, in a relationship where a higher concept would have parts that all the other concepts has, but they add to it. So you have a concept of vehicle, which could be anything that is moving. And a vehicle, the motor can be a motorcycle, a car, and a truck. All vehicles have wheels. All vehicles have engine. All vehicles have maybe light. But some vehicles have two wheels, like a motorcycle. Some vehicles have four wheels. Some vehicles have 8 or 10 or 6 wheels. Some vehicles have no doors. Some others have 4 doors. Some others have truck. And within the car type of vehicle, there could be different types as well of a car. Like a sedan is a type, an SUV is another type. What you see common among all of those is that a vehicle is a concept that contains very general idea of what a vehicle is. The things that has to exist in all vehicles regardless of their type. Then each particular vehicle type, motorcycle, car, truck, has their own speciality that specifies the generalization that exists in the vehicle class, and so on. You can have a multi-level hierarchy of classes, inheriting classes, inheriting classes. When you look at the API documentation, you see when the documentation writes a class, the first thing it says what classes it inherits from. So, for example, in the graphical user interface, we have the JComponent class, which we all inherited in our programs. This class has a method to provide the width and height, which is all components will have width and height. And there are multiple types of components that inherit from this class, and we had our own component that inherited from. There's a JPanel class, JText component, JLabel, and then you have an abstract button. An abstract here meaning that it's not an implementation, but it's just a definition. And from the abstract button, there's a J button, there's J toggle button, which has a J radio button and a J checkbox. From the text component, there's a J text field, J text area. Each one of them is a specialization of the generalization that exists in the class. What you see in front of you is part of the hierarchy of a package called the swing package that manages the user interface. The J in front of them, at the front of each class name, meaning that they belong to the swing package. And this is probably what you will be using most often. These different components. You'll be using the text field, the label, the button, checkbox, radio button, maybe a text area, and the JPanel is an invisible component that allow you to contain several other components in it as well. So in banking, the same thing. A superclass can be a bank account. Subclasses can be checking account, saving account, youth account, all of these different things. So here is an example of a hierarchy, and this is how we draw it. So this is saying that the checking account extends bank account. A saving account extends bank account. So if bank account has 3 methods, deposit, withdraw, and get balance, the saving account also has all these 3. You don't see them here because you don't have to rewrite them, because you already inherit them by extending the bank account. So the saving account will have all the methods in bank account plus its own methods that it defines. Checking account is the same. So checking account here has additional 3 new methods in addition to the 3 methods that exist in the bank account. This is how you define the relationship by using the extends keyword. Every class, like class saving account, can only extend one other class. You cannot extend more than one class unless you go up in the hierarchy. So saving account extend the bank account, then you have a bank account extend something else. But you have to extend one class at a time. And here is the same discussion that we had earlier. And here's an example of building the saving account, extending the bank account. These two slides talk about a common error. If the bank account class has a variable called balance and has a method called getBalance, the common practice is you always make the variables private and you provide accessor methods, a set method and a get method. So in the subclass savings account, you use those accessor methods, the set method and a get method, in order to access the private variables. Now, sometimes you say, well, let me put the balance, the name of the variable directly, but if you make the variable private, you will not be able to access it, so the compiler will complain here. And if you decide to redefine it, like if you put the balance and the compiler give you error and then your development environment suggests to you to redefine a variable, you may this may work, but what's happening is this balance in saving account is hiding that other balance in the other class, so you don't want to do that, okay? Because you miss the represent the data in the class, and things are not gonna work the way you want. So do not use the same name in the subclass as a variable name in the superclass. And we made the same comment before when we talked about methods. We said do not use a variable inside the method that has the same name as a class variable. This same concept here applies. A subclass method, so you can have a method in the superclass and you come in the subclass and override the definition of that method, which means that you say, well, this is how it is implemented in the superclass, but I want to provide something else. So method overriding happens when a subclass provides a different implementation to a method that exists in the superclass. So if you have a bank account class that has deposit, withdraw, and get balance, and then you have a checking account that has a deposit and withdraw, so this is an overriding of deposit and overriding of withdraw. You provide a different definition. All right. Subclass construction. If when you create a constructor for the subclass to initialize its variables, it is usually common to call the constructor of the superclass in order to provide any initializations that the superclass need to perform. You use the keyword super in order to do that. So when you say super and you pass on a variable, it is actually calling a corresponding constructor in the class that is a superclass. So the keyword super is a reference to the superclass, and there's the keyword this, which is a reference to the current class. Now, this topic, converting between subclass and superclass, it's an important topic, may confuse you a little bit. The best way to think about this topic is to remember back when we talked about the primitive data types and we talked about the variable long and a variable integer. At that time, we said that since the variable long is bigger than the variable integer, you can take a variable that is integer and assign it to another variable that is long. But you can't do otherwise. You can't take a variable that is long and assign it to a variable that is integer. The concept applies here as well. Since the superclass has everything, or that since the subclass has everything that the superclass has, all the variables and all the methods, you can assign a subclass object to a superclass reference. But you can't do other way around. You can't have, since the subclass has more methods than a superclass has, you can say that a subclass reference would represent a superclass object. It won't. Okay? It could be a little bit confusing. So if you have a saving account that is a subclass of a bank account, you can take a saving account object, like college fund in this example, and assign it to a reference of type bank account. In the past, we would tell you this is like this bank account is the long, and this one is the integer. You can take a variable of a different type and assign it to a variable if the different type was a subclass of the reference. Okay. So if you look at the hierarchy that we had earlier, you can have a JLabel object and assign it to a JComponent reference. But you cannot have a JComponent object and you assign it to a JLabel. So you can go from the bottom up, but you can't go top down. So if you have an object of the type that is lower in the hierarchy, you can assign it to an object that is higher in the hierarchy. But you can't go down. That's what's basically this part means. Okay. So there is some discussion here. If you want to know what the type is, there is an operator called instanceof. This is usually used in combination with if statement if you want to check if an object is part of the hierarchy of another, of a class type. So if you have an object and you're not sure if this object is of type that belongs to the bank account type, maybe bank account has so many children or so many subclasses that you no longer know if an object belongs to it or not, the instanceof operator will return true if an object is instance of a type and will return false if an object is not instance of that type. There is some good discussion here for your own reading if you want. So you wanna spend some time looking at that and seeing how much you can learn from here. Now, since we have those relationship, we said that if you define a variable in a superclass as private, the subclass cannot see it. When a variable or a method is private, it's only accessible within that class that defines it. So what if you want to define something in a class and you only want the subclasses to have access to it but no other class? This is the access type that's called protected. If you define a variable or a method like in the example you have here and give it the access protected instead of private or public. Public means that every other class, regardless of the relationship, will have access to it. Private means no other class will have access to it. Protected means it's only this class and its subclasses that will have access to it. So if there's something that extends bank account, they will have direct access to this variable that is defined as protected. There is a class called object. This is the parent or the superclass. This is the top hierarchy in the Java classes is called the class object. Automatically, every time you create a class, it automatically extends this object class, even if you don't say extends. So all the classes we created, we never really used extends, but we were actually extending the object class. This object class has several methods that are useful. The toString method, which provides an implementation, a string representation of your object, equals method, which tests for equality, and clone method, which makes a clone of the object. If you want to create your own data type and you expect it to be used, it is generally recommended that in addition to the methods that you have, whether it's set and get methods or other types of method, you also provide implementation of these three methods as it applies to the data type. The rest of those slides, or the rest of this chapter, is walking you through example providing implementation for these three different methods, and it is straightforward. You can read it yourself directly. Time is reached 20 minutes here, so I'm going to stop here, and I'll see you in a different video. Thank you.